Parallel lines. The definition we're going to use for parallel lines is the following. Two coplanar lines that never intersect. Some parallel lines might be like the yard lines. And how about this guy here? There would be some parallel lines. And we'll mark them parallel. This is kind of important. We'll mark them parallel on a drawing or a diagram. You'll see arrows in the middle of the lines. So when I mark lines parallel, I'll mark them parallel kind of like this. And there's like little arrowheads in the middle. Just like we saw with segments, if you have like a hash mark for two segments, that means they're congruent. If you have the same like arc for an angle, the same number of arc lines tells you this, that those particular pairs are congruent. Similar with parallel lines, if you have the same number of these like little arrowheads in the middle, then those lines are parallel. The lines have the same number of little arrowheads. Okay. So can you give another example of a set of parallel lines?
The seat rows on the straight sides.
Like these seat rows?
Yeah, like not on the curves, on the corners, but like the straight ones.
So like seat row and seat row?
Yep.
These would be parallel. I'll mark them, since these are differently parallel than these, I'll mark them with the double arrowhead to say that they're a different set of parallel lines.
The two eyes in Michigan.
Another special relationship that we aren't going to deal a ton with in this class is we're going to focus mostly on what's called two-dimensional geometry, like flat spaces. But they do come up. Skew lines are lines that also don't intersect. But they do it in a different fashion. Skew lines are two non-coplanar lines that never intersect. Skew lines aren't on the same plane. So that means they're like above or below. That means that they're like on kind of moving in completely different directions. And we think of skew lines are mostly in terms of like three-dimensional space, are like skew lines. They're not coplanar, so they're not on the same plane, which means they'd have to be like on a plane, like the two planes would have to be like above or below each other, or they'd have to be left and right of each other. Like if you're in, say, in this classroom, example of skew lines might be like one of the runners that are on the ceiling, like going from front to back, and then like say the edge of the metal board here. They go in different directions and they're on different planes. They're above and below and they're moving in different directions. They're skew lines. Okay. With this brings us to kind of the foundation of how we're going to proceed in the course. And the idea of what's called Euclid's parallel postulate. Basically, from here on out, the rest of geometry, the rest of the things that we do in this course are founded on that idea. We're not going to cite this idea that often, but it's kind of in the background. It's going to be what kind of allows us to do the things we're going to do in geometry. I want to draw a picture first, and we'll write the definition down. Okay. So bear with me. Imagine we have this situation. Imagine we have a point. I'll call this point point P. We have a point somewhere on a diagram. And we have a line that's not through that point. So we have, like, say, this line. And I'll call it line L. Imagine you have this situation. How many lines through point P can you draw that are parallel to this one? 1. Euclid's parallel postulate says that. That's all it says. It says if you have a point and a line that doesn't go through the point, there is one line you can draw that's parallel to the line and through the point. Well, let's formalize that a little bit more. Euclid's parallel postulate says that given any point and a line not through the point, then there exists one line through the point and parallel to the line. Anyways, the perpendicular postulate is word for word the same as the parallel postulate, only thing you replace the word parallel with perpendicular. It says given any point and a line not through the point.
Can we just write ditto except
Sure.
perpendicular?
I mean, it's your notes. Do what you want. Then there exists one line through the point and perpendicular to the line, with the upside down T as the symbol for perpendicular. The word transversal is just a line that intersects at least two other lines. So a diagram might be, how about if we have a line and maybe another line? We could draw a transversal through them. You could draw a transversal through them that intersects both. So like, might be a transversal. Boy, why did I write the word transversal as two separate words? Would be a transversal. It cuts the line. It cuts two different lines.
That sounds like a made-up word.
Corresponding angles. If you have a picture like this, corresponding angles are angles that quote-unquote match up. They're in the same spot. In the same spot, two ways to remember it. Or if you're like a visual person, they make what's called an F pattern. Okay? So let's see. If I had, say, how about if I look at this pair, if I look at that grouping of four angles that are made, how about if we look at, say, the upper left angle? The angle that matches up, that's in the same spot, in the bottom pair has got to be the upper left angle here. Notice that if I draw in the sides of the angle, if you draw in the sides of your two angles, you get yourself, in this case, like an upside down F. That's why I call it an F pattern. Okay? They're corresponding. These angles correspond. Those angles correspond. Those angles correspond. They match up. They're in the same spot on the diagram. Upper left, upper right, so forth. Or they make an F when you intersect them. Alternate interior are interior or inside or between the lines being intersected, and opposite. So between the two lines, here are my two lines. Between the two lines, there's got to be one of these four. If I choose, say, 1, then opposite of this one on the inside would have to be, say, this one. Inside and opposite. If you draw in the rays, you get this. This is also known as a Z pattern. And again, the other pair fits as well. It's a Z pattern of angles. Alternate exterior, opposite and outside. Outside and opposite. So outside of the two lines being cut, and then opposite of each other. So like you could have this pair, and then its opposite and outside partner would be opposite and outside. Would be like this pair. I don't know what you want to call it. I've called this in the past the broken X. If you want to think like and say with letters. I don't. There's not really a good one for this one. Outside and opposite is how I remember it. I don't think about this. I think about like an X that's been split up maybe. The last one is consecutive interior. Consecutive being same side and inside. Same side and inside. So if I inside and then same side. Same side and inside. If we're thinking a letter, what letter we want to call this?
U. Right. It does like a pair of pants.
I call it the C pattern because you could have also done that pattern as well, is also consecutive interior. Okay.
Is it just me or is it pants?
Sure.
Okay.
Big jeans. Okay. In your document, I'll do one pair for each of these. You can fill in the rest before you head out. So corresponding, you could have, say, angles 1 and angle 8 would be one pair, and there are 3 others. Alternate interior could have, say, like angle 2 and angle 7. Alternate exterior could be like, say, angle 4 and angle 5. And consecutive interior could be like, say, angle 2 and angle 8. There are 3 others, and 3 others corresponding pairs, and 1 other for each of these. You fill them in on your own. Your homework is